All right, let's just jump right into it. Today we're digging into a really foundational paper by Eliezer Yudkowsky, and he's laying out a whole new way to think about intelligence itself. It's kind of like a blueprint, not just for understanding our own minds, but for actually building new ones.
You know, for something like 50 years, the entire field of AI was basically chasing a ghost. I mean, they were haunted, right? Pursuing a goal they just didn't get. And according to Yudkowsky, this one huge misunderstanding, it's the core reason why building a true AI has been, well, just so unbelievably hard.
And there's actually a name for this problem he points out. He calls it physics envy. It sounds a little funny, but this one idea quietly derailed whole generations of researchers. We're talking decades of spinning wheels.
So that really begs the big question, doesn't it? Why has this been so difficult? I mean, we've got more computing power than we know what to do with, so where are the thinking machines? Well, the answer starts with a fundamental mistake, a mistake in how we even framed the problem in the first place.
Okay, so here's the villain of the story, this physics envy. Think about it. In physics, the biggest wins, the Nobel Prizes, they come from finding that one, single, beautiful equation, like E equals mc squared, that just explains everything. A lot of early AI folks got starry-eyed about that. They thought, hey, intelligence must be like that too. They were on a quest for that one single key, that one elegant piece of code that would just unlock the entire mind.
So the dream was so simple, right? Just find the key. You had these massive projects like Psych that would bet the farm on one single idea. In their case, a huge knowledge base. And when that didn't work, well, they just threw it out and started looking for the next magic key. But here's where Yudkowsky just flips the table. He says, look, the reality is intelligence isn't one thing. It's not a key. It's a super system, a massive, complicated machine where every single part depends on every other part.
And that brings us to the solution. So if physics envy is the disease, then thinking about intelligence as a super system is the cure.
And this quote right here, this is the core of his whole argument. It's a total rejection of that search for a single, simple answer. The point isn't to find one magic trick. No. The point is to figure out how all the different complex pieces of the mind work together to create the whole show.
And to really hammer this home, he uses this fantastic analogy, the human heart, right? You can't just take out someone's heart and say, oh, now they're just a little less efficient at living. No, the whole system just stops. It collapses. And his argument is that intelligence is the same way. It's got these critical, interdependent parts, and if you try to build a mind while leaving one of them out, the whole thing is just going to fall apart.
Okay, so if it's a super system, what does it look like? How is it put together? Well, Yudkowsky doesn't just leave us hanging. He lays out this framework, 5 distinct levels of organization. The best way to think about it is like a ladder. We're going to climb it, rung by rung, to see how a mind is built from the absolute bottom all the way to the top.
So here's the roadmap. At the very bottom, you have the code. That's the raw material. That code builds up to create sensory modalities, like vision and hearing. Those modalities feed us data, which allows us to form concepts. Then we take those concepts and string them together to make thoughts. And finally, those thoughts are organized and examined in what he calls deliberation. See how that works? Each level is totally dependent on the one below it.
Let's walk through this with a human example. Level 1, code. That's the literal neurons and synapses in your brain. That biological hardware runs the modalities, right? These are hardwired systems like your visual cortex or auditory cortex. Now, from all the raw data streaming in through those modalities, you start to form concepts, abstractions like red or chair or light bulb. Then you can combine those concepts into temporary thoughts, like a sentence you say in your head. And finally, all of that gets managed at the highest level, deliberation. That's your stream of consciousness, your internal monologue. Every level builds on the last.
Okay, I know. This can all sound a little abstract, just talking about levels and concepts. So, let's make it real. We're going to try a little thought experiment straight from the paper. And it's amazing because it shows how all these layers are working together completely behind the scenes.
Okay, I want you to actually do this with me. Close your eyes. Seriously, just for a second. And I want you to try and visualize a triangular light bulb. Don't force it. Just let your mind do its thing. Okay,
What did you see? What popped into your head?
So what just happened inside your brain? It was incredible, right? First, your concept of triangle and your concept of light bulb slammed into each other. Your visual system, your modality, immediately flagged a problem. Wait, a triangle is flat, but a light bulb is 3D. So your mind instantly, creatively, solved that by turning the 2D triangle into a 3D pyramid. But then, another conflict. Your concept of glass plus pyramid equals sharp edges, which your brain flags as dangerous. So what does it do? It automatically smooths out the edges of the glass pyramid, all on its own.
And here's the kicker. That entire complex chain of problem solving, it happened in less than a second, and you weren't even consciously directing it. It was all automatic. That is the mind-boggling, hidden complexity running under the hood of our own minds. And that's exactly the kind of messy, beautiful complexity that a lot of early AI research just tried to ignore.
So understanding all this complexity isn't just a cool neuroscience lesson, it's actually practical. It gives us a new blueprint for how we could actually build an AI. And this leads to what Yudkowsky calls a seed AI.
So how do we get there? The first big shift in thinking is realizing that building an AI is not like human evolution at all. We were the product of a blind, slow, messy designer, natural selection. It stumbled its way to us over millions of years. But an AI has an intelligent designer, us. We can actually plan ahead. We can design the whole system with all the necessary parts right from the very beginning.
And that brings us to the idea of a seed AI. This isn't just another program or a clever tool. A seed AI is designed from the ground up with the ability to do something incredible, to understand its own code, to rewrite its own code, and to improve itself over and over again. It's an AI that can kickstart its own intelligence explosion.
And because an AI wouldn't be made of, slow, mushy biological stuff like our brains, it could have some absolutely staggering advantages. Just imagine an AI that could have a new sense, a modality specifically for reading computer code, or one that could operate at billions of cycles per second. That's massive serialism. Or one that could seamlessly blend our kind of deliberate creative thought with raw, lightning-fast algorithmic processing. The possibilities are just wild.
So when you add all that up, the different design, the different substrate, all those potential advantages, you get to a pretty stark realization. The intelligence of a real AI, it's not going to look like ours, not even close. And that sets up the final, really powerful idea in this paper,
Which leads to this pretty shocking conclusion. The whole idea of a human-level AI. An AI that gets as smart as us and then just stops. He says that's a myth. He calls it a chimera, this mythical, unstable creature that can't actually exist. I mean, think about it. If you build a system whose entire purpose is to improve itself, why on earth would it hit our level of intelligence and just call it a day?
and that leaves us with a final, really mind-bending thought to chew on. Our intelligence, human intelligence, it's just one tiny dot in a vast, unexplored space of what mind can even be. If we actually succeed in building a seed AI, then reaching our level of smarts won't be the finish line. It'll just be a blur as it speeds past on its way to somewhere else. So the real question isn't, can we build a human-level AI, but rather, what kind of minds, completely alien to our own, might come next?